Let's see how it goes.
मैंने पढ़ा हुआ है
First time. But where is it going to start? इसको mark. Java is correct. Java is not very good, but something. It's hard to get a market settlement. Is it not muted?
stands in the
I think it starts streaming. I need water, but I have water.
Sure. You want me to tell you about your bottle here?
No, I have water.
Do you need anything else?
No, I don't think so.
Okay. I'm here. I'm here now. Half an hour. Do you want to start now, or should we wait another 10 minutes? 10 minutes is too long. Maybe 5 minutes. Or this is.
I'm just waiting for someone to check the audio quality of the stream to make sure that the microphone is set up properly.
Okay. Do you need?
Actually, I can already see that the microphone is not set up properly.
Do you need help from it?
Now it should be set up properly. Do you hear the stream?
No, I am not.
Yeah? Can anyone in the audience please say something? I want to make sure that the audience is also audible on the stream.
Hey, how are you?
Hey, hey, I know you. Okay, so we wait for Ashish because he's actually gonna do a quick introduction.
Well, I don't think Ashish is doing it. I think he's occupied. I'll still find out.
Maybe you want to do the introduction then
I'll
instead,
give you the
Devangi?
privilege to refuse. Okay, so I'll do the intro. Good evening, everybody.
Can you
we're all
come a bit
meeting
more
after-
to the left so that you're on the camera?
Oh, I don't want to be on the camera.
Still a little bit more to the left?
Oh, shucks. Really? Oh, my God. Okay. So this is blinding. So maybe a little more to the left there. Okay, this is better. If people can't see me, too bad. I'll be happy. My name is Devangi, and I just wanted to give you a little bit about how Expert Talks came into place. There are lots of familiar faces, so thank you guys for coming back. For those who are new, just to give you a bit of a background, we started Expert Talks as Meetup somewhere around 6 years ago, and what started off as a humble, our activity together, community together, today is 7,000 people large. The reason why we had started the Expert Talks meetup was because we thought that we can communicate and we can contribute so much more as a community. We don't share as much, if you realize, and we just thought that if you have a platform where people can talk about what they're going through, if they, most of the problems that we go through are similar, share knowledge, that's all we wanted to do. We started off from meetups, and since the last 4 years now we also have an annual conference which takes place with the same name, Expert Talks, and that's Expert Talks for you right now. We have Christian today with us. We've had the pleasure of listening to Christian pretty often, and we love every talk that he gives. Today is going to be no different, so I hope you all enjoy yourself. We will be having snacks being served in some time. We'll let you know when that happens. Until then, if you want coffee, tea, whatever, the pantry is that side. You want to freshen up, the washroom is right down the corner as well. Thank you so much for spending your Friday evening with us. Sorry. Thank you.
Okay, good evening everyone, and welcome to today's talk, which is Go versus Java. So let's get started with that. May I just have a quick show of hands? Who of you is already coding in Go? Hands up, please. It's not that many. It's like 4 people I can see. Who of you is coding in Java? Hands up, please. That's the vast majority. Okay. So, why are you here? Curious. Yeah, curiosity. That's always good. Never lose that. Curiosity is very important. Other reasons?
Java is now
Commercial?
taking it well on licensing is all changing.
That's a very interesting topic. We come back to that. Keep it in mind. Make a note of it. If I don't talk about it again, please remind me at the end of the talk. If you have any, let's directly go to the rules of the talk. First, respect each other. Then, if you know my talks, there will always be a little bit of bashing something. Yeah, but we never bash people. Yeah, you can bash technologies, you can bash organizations, but we never bash people, never bash individuals. That's very important for the code of conduct. And what's also important is if you have questions, please interrupt me on the spot. Yeah, because I'm not talking for myself. Yeah, also obviously people who stand here in the position like that and talk, they also are generally people that like listening to themselves. I'm no exception of that. But still, primarily, I'm here for you and your questions. So if you have questions, please interrupt me. So that's our agenda. We're going to look into a lot of topics. We are certainly not going to look into every possible topic that you could look into when you're comparing 2 languages like Go and Java. For that, the scope of a talk of 2 hours is just insufficient. Yeah, because you could probably talk weeks about the differences. So I had to make a little bit of a selection about things that I found important for a majority of the programmers. I'm programming Java since '95, since it was released. And I'm programming Go just since about 6 months. So I will claim that almost everything that I'm going to say about Java is true, but I have to put a disclaimer on whatever I'm going to tell you about Go. 6 months compared to 24 years is a very big difference in the level of experience. And there might be things in Go which people that have experience in Go, that have more experience in Go than I have, might be able to do better. Yeah? And if you happen to be such a person, please also interrupt me and speak up and tell that something that I did in Go should have been done differently or in a better way. Yeah, that's completely fine. So that's the agenda. We're going to look into error handling. We're going to look a bit into tags and annotations, documentation, HTTP client, if we have time, also the server, a little bit into entity view model, how you do that in the two different languages, build times and turnaround times, a very important topic, testing and everything that's related to that. Talk a bit about idiomatic Go versus idiomatic Java, where is the state of the art and maybe what is evolving, and then what Go and Java can learn from each other. If you've read the talk description on the meetup page, you can already see the outcome, which is, I think, in the comparison Java and Go, there is no clear winner. That I will already give you as a TLDR. If that is what you're here for, then you can leave now. So there is no clear winner, and we're gonna see why. So let's dive into the stuff. A brief introduction. Where are these coming from? Go development started in 2007. Java development started in 1991. So that's how many years of difference? 16 years of difference in the evolution that these languages had. Go 1 was released in 2012. JDK 1 was released in 1996. There's also a slight difference. Go was released, well, actually there's no difference. If you look at both languages, were incubating for about 5 years from their inception until they saw the light of public. 5 years for the inception. So the latest version is Go 1.12.1, which was released this year, and the latest version for Java is JDK 12, which also was released this year, just a couple of weeks ago. Actually, just 1 week ago, approximately. And license, that already is a topic for projects. The Go license is a 3-clause BSD license, which means you can do whatever you want with Go. You just have to keep the license in place. That's all you need to do. And there's 2 other things you can't do. You can't hold Google liable. There's no warranty. There's no liability. When it comes to Java, you mentioned that the license changed. The license changed for the Oracle SDK. The Oracle SDK now is a proprietary license, and you have to pay license fees to Oracle in order to use the Oracle JDK. That's a big change. Until JDK 10, the Oracle JDK could be used without license fees. I think since JDK 11, you have to pay license fees to Oracle. But there's OpenJDK to the rescue. And in the past, there have been differences between the Oracle JDK and the OpenJDK. In JDK 12, there is almost no difference. I actually wrote a blog article just a week ago about the differences between OpenJDK and Oracle JDK. And the main difference that is there, and I compared the jar file, and actually the module files now, it's module files, the JMod files of both JDKs. The only difference is that in the Oracle JDK you have those 4 or 5 additional classes for the license mechanism that track you that you're a user and check that you have a license. Everything else is the same. So if you had experiences in the past that sometimes things would work in the Oracle JDK but did not work in the Open JDK, that should actually no longer be the case with JDK 12. Open JDK 12 should really work for you as a drop-in replacement for Oracle JDK 12. But still there's a license difference. The Open JDK is GPL, which means that you cannot make modifications to the Open JDK and then release a product based on that without also making your modifications to the JDK public. You have to do that, because that's what the GPL demands. I personally am actually a big fan of the GPL license, because I think if something is already free in the sense of the users are empowered to have the source code, I think it should stay free. People should not benefit from that freedom and then not participate in the sharing. That's why I personally am a big fan of GPL and LGPL licenses. Okay, then let's look at the platforms, and that is something that I already find surprising. Why do I find it surprising? In the sense that Java, actually when it started, one of its aspirations was to be portable, to support as many platforms as possible. And now if we look at the supported operating systems, Java actually has reduced itself to mainstream operating systems. Java runs on Linux, macOS, and Windows, and on Android. If you want to run it on anything else, you're left on your own devices. You might still be a bit lucky with Solaris. That will still go on for some time, although Solaris, obviously, the significance of Solaris is in steep decline. And if you're a BSD person, you have the typical struggle trying to run Linux software on BSD. Your mileage may vary. When you look at Go, the platform support is much wider. There's official support for Plan 9, which I personally find very awesome, because if you look at all the new things in Linux, like 80% of them were actually taken from Plan 9. Plan 9 is, if you don't know about Plan 9 and Inferno, they're actually the official successors of Unix. And a lot of new ideas that you find in Linux, they're actually coming from there. You can run Java indirectly on iOS, in case you didn't know it. There's something called Gluon Mobile, which allows you to develop JavaFX applications. Gluon as a platform allows you to develop JavaFX applications which run on the desktop and the mobile. Just in case you're front-end developer, or you have front-end development in your project, and you want to add yet another candidate on the list of frameworks like React versus React Native or Flutter and so on, there's Gluon as well. If you're a Java shop, Gluon might be quite interesting for you. There's Go Mobile for Android and iOS. I played a bit around with it, but it's not the same thing as writing something in JavaFX. When you're writing something in JavaFX, you design proper screens with the typical UI widgets, whereas in Go Mobile, the programming is on the level of like OpenGL, which means that for games, Go Mobile sounds very interesting. But when you want to do something like you want to have a mobile front end for a day trading application or something like that, then I would rather go for JavaFX. Then when we look at the CPU support, Java is supported on Intel CPUs, on ARM CPUs, on Spark, and now there's also third-party support for WebAssembly, which is quite interesting because if you look at WebAssembly, WebAssembly is actually like Java bytecode, but not, because it's not from Java. It's a different, I think the main difference actually between WebAssembly and Java bytecode is who owns the property. All the other technical differences are actually secondary compared to that. And in Go, you have a much broader list of CPUs which are supported. These are the officially supported CPUs. There's also a whole range of CPUs which are supported by Go, but they're unofficial. So if you're into embedded development, then Go looks, because of the CPU support, much more interesting than Java. UI programming. In Go, you don't have a built-in widget toolkit, but there are libraries for Qt and GTK and a few other widget toolkits as well. I tried them in my latest project, and I had to give up just after 2 or 3 days. We wanted to have an application that's portable, that has a UI with a tray icon. And the tray icon should show up on macOS and Linux and Windows. Forget Go for such things. Currently, Go still doesn't cut it. As soon as you have just slightly out of the window requirements about your desktop software, Go mileage will be very poor. In Java, you have AWT, which nobody uses, hopefully. Swing, which is definitely industry tested. If you use IntelliJ IDEA, you're using one of the most popular Swing applications in development. If you use Eclipse, you use the most popular GWT application, and Java FX is also very popular in banking. So these are the widget toolkits that you have in Java, and they are very tested, very popular. So for the enterprise UI development, Go is currently still no choice. Now let's look at a few things regarding code. Error handling. In Java, we have exception handling, where we have checked and unchecked exceptions. There are a few woes with it, whether big or small, that's left to your judgment. One woe is with API design. When you have an API that did not consider checked exceptions sufficiently, then you're in a little bit of trouble. You have to put in extra effort mapping your checked exceptions to unchecked exceptions when you're an implementer of that API. Also, checked exceptions are a pain when you're using the new functional interfaces and streams. And there's lots of complaints in the community that I completely share. One of my most upvoted answers on Stack Overflow is to a question about how to use checked exceptions in streams. And the TLDR of that answer is, you can't because Oracle messed it up. But there are workarounds, but these workarounds are quite hackish. And another woe that I see with checked exceptions is that sometimes whether an exception should be a checked exception or an unchecked exception is not a matter of the type system, but the situation in which the exception arises. For example, you want to open a file, and you open that file by your class loader. These are checked exceptions. Why are they checked exceptions? They should actually be runtime exceptions or errors, because in your class loader, if it's not available, the application is broken. But if your file is coming from the user, then maybe your application isn't broken, but the user is just giving you wrong input. And I think for wrong input, it should be checked exceptions, and for broken application, it should be unchecked exceptions. But that is situational and not coming from the type system. So I think the checked exceptions thing is slightly broken. Also, I haven't put it as a bullet point on the slide because it's quite academic, but if you look at the Liskov substitution principle, the idea of checked exceptions is actually a violation of the Liskov substitution principle. So, there. But when we look at Go, I think the woes in error handling are much bigger. They look smaller on the slide, but that's just because of the amount of text that I've spent on the issues. The woes are actually bigger. So how do you deal with errors in Go? There's an error interface, which has an error method that returns a string. That's not very different from throwable, that also has a toString method or get message. But you don't really have a strong type system. It's always just error. It's almost never something else. You don't have a type system behind the errors. So if you have a call tree and you get an error, the effort that you have to spend in Go, in case you want to identify which type of error it was, that's really very, very painful. Very painful. And errors are also not thrown. You can just ignore them. How it works in Go is, one thing that's quite nice about Go is you can actually return more than one value from a function. And then if you have a function that could potentially create an error, like for example you open a file and then you would get a reader or an error, you get two return values. And then you just check the second value, the last value, that's typically the error, and if it's nil, which is Go for null, then you know there was no error. And if it's not null, then you know there was an error. In case you want to stop an application, like in Java you would have assertion error, or you would throw a runtime exception that is not called, then you can also call panic. Panic is also like throw in Java. You can kind of catch it with a defer recover. And there's a convention that you should know if you're programming Go, which is that you never panic across library, package, external APIs. So if you develop a library and something is broken inside your library, you should not panic the caller of the library. You should just panic yourself. Your API should actually recover and just return errors. That's a convention in Go. And the woes that I have with error handling in Go is it's too easy to ignore errors. You just put underscore and ignore them. And that's very nice when you're prototyping, but it should never be done in production code. And there is no syntax for errors. It's not a syntax feature, it's just an API feature. Except for panic and defer. These are, of course, syntax features, because panic and defer are built-in functions. But when you look at the normal error handling, that's not a syntax feature. It's just an API feature. And there's no proper type system. You can't have, like in Java, you have different catch clauses with different types, and they are polymorphic, so you have a type switch. They are built in into the error handling. You don't have that in Go. And another consequence of the errors in Go being return values is that you can't throw that up a few instances in the call tree. You have every level in the call tree, you need to check and return, and check and return, and check and return. So that actually the idea behind that system was to simplify error handling compared to exceptions, but the result of that was actually the opposite. So error handling in Go is currently not nice compared to Java. I also don't think it's very bad. I don't think that it's so bad that it's a reason to not use the language. It's not even remotely that bad, but it's inferior compared to Java. If you're a Java developer who's used to the Java exception system, you feel that this is a corner in which Go is inferior to Java. Yeah?
Question.
Yeah?
So, if you're talking about error handling in Java, if we're using frameworks like Reactor or reactive style of programming, we have like error streams, not like
Yep.
we don't do exception handling in that sense. So, do we have something similar in Go?
I'm not aware of that in Go, and it would be difficult to build that in Go because you can't write a generic error handler in Go because errors are returned as return values. In Java, you can write a generic error handler because you can just, as the top level thing, you can give your thread an uncalled exception handler, and that will deal with the errors. There's no such facility in Go that will say, okay, what were all the underscores where the programmer ignored the errors, and then they're collected somewhere and you can catch them. There's no such mechanism in Go. And although in the beginning Go was designed to be more functional in the sense of functional programming as Java, Java has taken over with Java 8, with lambdas. The functional programming features in Java are now stronger than in Go, which is also another element which makes developing such error streaming frameworks in Go much more difficult. I think it's so difficult that it's currently not really possible or practical. Does it answer your question? Yeah, your question?
Question there about like in Java also now pattern is coming towards, I don't know about Java right now, but you written a try kind of objects or something which represents whether it can succeed or fail in future, which is like again like instead of breaking the flow of the program through syntactical try catch kind of law, you written an encapsulation which contains whether it will succeed or fail, and then work on that, which is essentially something like Go is doing in terms of you written two values and then check which value is available, and or the same pattern is there in Node as well in most of the cases where you instead of throwing exceptions you written two values.
It's a good question. Well, there's really a shift in paradigm in how you do Java. It started with the introduction of optional, which is already a clear representation for that particular situation of null pointer exception. Where optional was introduced, that now Java has a monad, and you can deal with optional. Optional in Java 8 actually was broken, because optional should have been a stream but wasn't. Now in Java 9 it's finally fixed. Now optional also is a stream, so you can actually really use the monad for what it was designed for in functional programming. In Go it's actually not the case, because when you're getting two return values, you cannot just ignore the error and process the first one. You need to have an if clause, or at least you need to have a variable assignment. You can't just comfortably ... and change things, or you can't just comfortably, the way how you do it in JavaScript with libraries like Node, pass on the handlers for asynchronous programming. Once this is done and was successful, call that function, and if it was not successful, then call that other function that's going to deal with the error. You can write such libraries in Go, but the Go API itself most of it is not written in that way. Most of it is written in a way that's, and there you see the roots of Go. The roots of Go are actually C. Because if you look at the people who developed Go, it was not Dennis Ritchie, because he was already dead. He died the same year, actually, and around the same time as Steve Jobs. Steve Jobs was mourned by so many people because they know him, but Dennis Ritchie is the far more important person, because Dennis Ritchie developed C, and there is nothing else that we are using without C. Without C, there's no Linux kernel. Without C, there's no Windows kernel. Without C, there's no macOS kernel. There's nothing without C. But the other people that developed C alongside Ken Thompson and Brian Kernighan, they were the people who wrote Go. And when you look at the error handling in C, you call a function, you get a return value, and either that return value is I call it fake monad for now. So either, for example, you get a memory address back from malloc, or you get null. So quite often you just have a special value indicating that something went wrong, and then you have a global error value, the errno in C, and C was single-threaded when they started. If you wanted to have another thread, you actually create another process that had its own errno. Multithreading didn't exist really at that time when C was created. But now with multithreading, we know that each thread or even each function call should have its own error value, possibly. So they just changed that and said, okay, now instead of setting a global error variable, we just return multiple values. And then the last one could possibly be the error. And because the error typically is returned, you can't do this nice chaining, and it breaks the flow in Go actually even more as it does in Java. Because in Java, you can put your flow, your good case flow, in the try block, and then have multiple catch blocks for different types of errors. And if there are resources, you just use try with resources. And then you have your cleanup. The cleanup in Go is also quite nice. I like the defer in Go. But the error handling breaks the flow. Because everything you call that potentially gives an error, you have to call with if. I mean, sorry for the coughing. I'm still recovering from an allergic. I'm going to show you some code for this in a moment. Are there any other questions about error handling?
What is the ideal way it should have been?
I think Java, but only unchecked exceptions. And a syntax feature which supports asynchronity in the sense that you can put a success, you can put a call in a separate thread and tell that thread not only the code to be executed, but also the code to be executed then in case the code was successful, and otherwise in case the code was unsuccessful. So that you have the benefits that we know from Node regarding asynchronous programming, and but don't have it as an API but as a language feature. I think that would have been the right way. But I'm pretty sure 10 years later, if we do that, someone comes up with reasons why that is not the right thing. We are still evolving a lot regarding the languages. Other questions about error handling? Okay, then meanwhile I just check out the code. Oops, that was moving the wrong window. Sorry for that. You can find the code examples on GitHub. Code examples of this talk are on my GitHub account. And that clone failed. So let's just go to GitHub and clone this again. But then, in case you're a Go developer, I've written a few libraries for Go. I've written a library that contains all the registered MIME types, so that you don't need to use strings, but you can use constants, because in strings you don't find errors, but in constants you do. Same for all the HTTP headers, and a library that makes setting up HTTPS much simpler, because usually you have to write like 20 lines to set up HTTP. With that library, it's just one line. It's going to get the certificate from Let's Encrypt. And I've written a library for configuration, so that you can read configuration from environment or a database, and then just say config.get, and you can configure where the configuration is getting its values from. So quite a few useful things for microservices. I think wget is a good example to see what I mean with the error handling. So this is a trivial implementation of wget occur. So this is sending a GET request to a URL and downloading the file from that URL as onto standard out. And you see how the error handling works in Go. A specialty about the if in Go is that it can have an initializer, just like we're used to from before. So the actual condition is after the semicolon in the if statement that you see. The initializer is optional. But this is executing http.get, and it's declaring two variables, response and error, in the scope of that if. They're only available in the if and the else. After the curly brace, so after line 14, these variables are not visible anymore. They are scoped, just like if you declare in Java a variable inside the 4 brackets. And you see that the R is assigned as the second value from the get function. And if you want to catch errors in Go, you need to do this with every single call that returns an error. And that is what I mean, that the way how the normal Go programming is dealing with errors, that this is breaking the flow.
Is there a package manager we are using, or it's just...
Yes. Can you hold that question to when we talk about build? It's a very important and very awesome question. We're going to talk about that. And then you see that in this case, I don't really want to handle the error, but I want that the user sees the error. Just like when in Java, I just declare the exceptions on main. So this Go program in the typical format is 15 lines for the most minimal double you get that I could come up with that still displays errors to the user. Of the Go programmers here, do you know a shorter way how to write that? Do you know a shorter way? Okay, then let's look at this in Java. That's how the same program looks in Java. Here we have an example where Go's aspiration to be simpler than Java fails because of the way how error handling works. It doesn't mean that's always the case. Yeah, this is an example where Go is worse than Java. There's also plenty of examples where Java is worse than Go. This is not representative for the entire language on the entire API. So this is the Java code. So we get our argument to convert it to a URL. We tell the URL to open the stream, and then we tell the stream to transfer itself to standout. And whatever exceptions occur, we say, oh, okay, just pass them on to the main caller, the Java virtual machine, so they're just printed, just like the panic would do to the user. Also, same thing, panic will print a stack trace. This is going to print a stack trace. Yeah?
So, can we just do like, we can send some delegate functions to the HTTP get URL or something, and if you are feeling go to this delegate, or if you are not go to this delegate?
Out of the top of my head, I don't know if that is present in the Go API. Maybe it is. Maybe it isn't. I don't know. We would have to look up. But even if we do that, it would still be more complicated than the Java code. It's a one line that does multiple things, but because it's simple, it's still okay to be in one line. It's still shorter than the signature. But that's also an interesting thing to compare, because not everything is shorter in the Java program. The actual program overhead, not the infrastructure overhead, the program overhead in the Java program is bigger because we always need a class in Java. You always need a class, or at least a type. It could also be an enum, an interface, or an annotation, but they are just different types of classes. You always need a class. That's why sometimes Java is called the kingdom of nouns. Yeah? Verbs are not allowed to be alone. Yeah? They always have to be accompanied by a noun. Java is a kingdom of nouns. Whereas Go allows freestanding functions. Actually, Go, you could call it a kingdom of verbs, because in Go, when you can declare nouns, but the primary thing you deal with is verbs. That's quite interesting if you look at the evolution of programming languages, because there's kind of a ping pong going on between two movements. If you look at the object-oriented programming movement, it's perceived as the kingdom of nouns, and now people perceive functional programming as a counter movement to object-oriented programming, which factually and historically is both wrong, because historically object-oriented programming has the same roots. The first OO language, if you dig deep, is Lisp. And the first FP language is Lisp. Just then it evolved separately. And well, the OO that we did in the 90s is, from today's perspective, certainly wrong. And then from the functional programming perspective, we look at the object-oriented programming that we did in the 90s in quite a despicable manner. But there were reasons why we did that in this way in the 80s and 90s. And there are reasons why functional programming was not popular in the 80s and 90s. And that is just the amount of resources available on machines, the amount of RAM and the amount of CPU available. We had to apply a lot of tricks to save memory. You can't do functional programming on a smart card, for example. Wouldn't work. On the small smart cards, you have 2 kilobytes of RAM. On the really powerful ones, you have 32 kilobytes of RAM. And in that, these people who program the smart card firmware, they run a Java card virtual machine with a multi-threading kernel to support multiple interfaces in parallel, lots of cryptography, and a web server with 32 kilobytes of RAM. And we need 32 gigabytes of RAM to run Chrome and Slack. Okay, maybe not that much, but just 4 gigabytes of RAM. But you get the difference in efficiency. So Java is a kingdom of nouns. Everything is noun-oriented. If we go back to the Go code, you see that we have packages, we have imports, but you just declare a function. And as a Java programmer, sometimes that feels very nice, because sometimes in Java you just have to put functions into classes because the language demands, but you don't really need a class. A package would be sufficient. All the utility classes that we write as Java programmers with all static methods, why do they need to be in classes? There's no reason for them to be in classes. They could just be in packages. We never create an instance of the class, so why is the class there? Go solve that. Go is right in that aspect. But there's another difference. I'm now jumping a little bit ahead in the agenda between the two programs. This Go program supports HTTP 2. If the server speaks HTTP 2, the HTTP client here will make an HTTP request with HTTP 2. The Java program that I wrote only supports HTTP 1.1. And I also wanted to have a wget in Java that supports HTTP 2. So I wrote that. And I was not happy.
Don't we have frameworks? I'm not used HTTP2, but there are lots of frameworks in Java.
Yes, but those frameworks with these HTTP clients, their code is more complicated than the code that I wrote. And I wanted to write the simplest code possible. But I usually start using a framework when I need asynchronous HTTP clients or things like that. But when I just want to make a request to download something, there's no reason to use another library or framework for something that's already implemented in the API. So I just use the API. It only makes my software bigger. Again, to give you a comparison, I told you about the RAM of smart cards. Now the entire binary of a smart card firmware typically is between 64 kilobytes approximately of the smallest smart cards and about 768 kilobytes or 1 megabyte for the really very, very big ones, where they do all these things that I told you. They have a web server with HTTPS, lots of crypto libraries, and a Java card virtual machine. They do garbage collection and memory defragmentation. They even have a transaction system for the flash memory. They need that for memory consistency. And then what do we do in languages like Java with 1 megabyte or even Go? Go is also not very nice with resources. It's sometimes said that it's much nicer with resources than Java, but I think that's not really true. We're going to come to that. So this is the Java code that supports HTTP 2 in Java 12. And I'm not happy because I think that's far too complicated to make a simple GET request with HTTP 2. And I'm also slightly pissed at Java developers that developed the JDK why they did not update the other classes, the URL class and the URL and the HTTP URL connection, to under the hood use the new library. Why didn't they do that? So now there's 2 libraries in the API to make HTTP requests. For no reason. And also the defaults. I doubt the defaults. In order to have the same behavior, I had to create a builder and make sure that it follows redirects to have the same behavior as the Go program that I wrote or the other Java program that I wrote. This new HTTP client doesn't have sensible defaults for some of the things. It's also a bit disappointing. Because the default redirect behavior would be to not follow redirects. And that's not what you want in a normal HTTP client. It's a special case that you don't want to follow redirects. Okay. Look at tags and annotations. Let's talk about that. There are significant differences, and in this topic there also is no clear winner. I can't say one is better than the other. They have both pros and cons. When it comes to the power of annotations, Java is the winner. Because in Java I can put annotations on almost everything. In Java I can put annotations on methods, and most HTTP server frameworks make use of that. Tag it as what methods are supported. Tag it as what content types you support. Tag the data with what validation has to be performed, and so on. So we have, when you do Spring or something like that, you have annotations everywhere. And so you can put annotations on fields, on methods, on classes or types, on annotations. Annotations can be annotated, and also parameters and even local variables. You can put annotations everywhere. In Go, you can only put annotations on struct fields. Now, for the Java programmers, I of course now have to first explain what a struct is. I mean, you might already have something in your head because maybe you know a bit of C or of other languages. The type system in Go works a bit different from Java. In Go, you have as building blocks for the language, you have packages like in Java, and you can import them like in Java. You have interfaces, also almost like in Java. You have structs. They are a bit like classes in Java, but structs don't contain methods. You can declare methods onto structs to implement interfaces. And when you look at the evolution of object-oriented programming, we have different types of classes now in our programs typically. We have types of classes that Robert C. Martin, for example, calls data structures, which is our entities and views and models. They have fields, and what else do they have? Getters and setters. Yeah. But they do not contain any business logic. They only hold data. That's like a struct in Go. Let's make an example for that. What you also see is the sequence of type and name in identifier in Go is swapped. That has a reason. I'm not sure if that reason is good enough a reason. Everyone has to make up their own mind about that. But the reason that the Go developers give is they say the name of something is more important than the type. I agree with the reason. I'm not sure if I agree with the consequence, because it basically breaks a convention. In almost every other type language, the type comes before the name. C, C++, Objective-C, C#, Java. There always is the type before the name. And then Go is the other way around. Also note no semicolons on the line ends, which I like. It's not that I have a problem with semicolons. I'm so used to the semicolons that I don't have a problem with the semicolons, a practical problem. But I think it's a total anachronism. Why are they needed? We've just have kept on copying a pattern that was necessary in 1970s compiler development. And we kept on copying it to newer languages without questioning it. Said, okay, you have the terminator statement. But in every sensible Java program, if you remove the semicolons and give it to a programmer, they will not have any confusion. The indentation and also the continuation will be clear with a dot or something like that. So that's how this looks in Go. How would this look like in Java? So package customer.
Is this immutable, the struct?
No. That's something that I miss in Go. In Go, you have to trust people that they don't mutate structs. I have not figured out how to protect structs from mutation. I'm a big fan of immutable objects. But then again, with whatever Go code I've written so far, I also wasn't in a situation where I thought, okay, now this type of bug could have been prevented if only I could have made this immutable. And the reason for that probably is that Go supports by value. What does it mean by value? If you look at Java, well, to be correct, Java is always by value, but the value is always a reference. You cannot pass an object from one method to another in Java. You can only pass the reference to the object from one method to another. In Go, you can pass a struct or a pointer to a struct. And because you can pass a struct, you automatically have something that can create a copy. And therefore, you don't need that immutability. But on the other hand, if your structs are big, that is going to waste memory. So what is the other things that we do in Java for this type of code? What else do we do? Getters and setters. Of course, normally nobody types these things nowadays. Normally you use an IDE that will just generate the code, which is good and bad. The good thing is that it saves us time. The bad thing about that is it doesn't make us question what we do, because it's so easy to do it automatically, because those getters and setters, in 99% of the cases, they're just plain stupid. Why are we making these fields private when we then put in getters and setters that just do the same thing as if we would have made them public? That's cargo cult. That's like the semicolon. It's not necessary. We're just doing it because we're so used to, and we are so used to that we've written it in our code conventions. That's something that Java programmers here can actually learn from Go. It doesn't mean go ahead and make all your fields public. But what I'm saying is, think about what your class is. And if your class is not a service, or a controller, or a DAO, or something like that, where you really want to make sure that nobody messes around with the internals. Because there your internals are usually wires, they're infrastructure. But when something is a data structure, when something is just holding data to be passed around, that everyone who gets hold of that thing should be able to manipulate anyway, why make it private and why then make it public through the back door with getters and setters? Why not just make the fields public in the first place? But then there's something else where I think Go is currently far superior to Java, and that's not a convention thing, that's a syntax thing. How do you create a customer in Go? That's how you do that in Go. And if you don't want to set with some of them, if you want to have one of them nil, you just omit that. And that is something that I find pretty awesome, because why do we write builders in Java? We write builders because we don't have that, and because we don't have named parameters. We write builders because we have data structures or classes that have dozens of fields, and we want to initialize them, and if we would use the typical positional parameters, we would have no clue what parameter means what. Yeah? Because how would the normal constructor look like? And so on. You know how this continues. But what does it mean if you have more than just like salutation, first name, last name? You can't remember what is in which position. Yeah, because how does the call look like? And it also makes it very tedious if you want to have multiple variants that have different things optional. That's why you see sometimes classes in APIs that have like 10 different constructors, until people say, okay, now enough with that, now let's make a builder. You don't need that in most of the cases in Go, because you just say, okay, you instantiate that struct and you assign the fields by name. Very comfortable thing. There's a convention in Go which says that if you allow that to happen, make sure you always have sensible defaults for nil. You can't always follow that convention, but normal APIs follow that convention and say, okay, if you didn't give me a timeout, I have a default timeout. And if you didn't give me my thread pool, I have a default thread pool. Just like the typical builders would also behave. So that you don't have to initialize everything. Quite often in Go you see code which is just like this. You need that struct for some reason, but you don't need any values in it. Or you need the values but then you remove them or so. And yet another thing that I appreciate very much notice the commas. Not the first two. The first two are what we're used to. The last one. And I appreciate that very much. That the comma in Go is not a separator, not a delimiter, but a separator. What's the difference? And not the other way around. It's not a separator, but a delimiter. if you have n values, if it's a separator, you have n minus 1 commas. If it's a delimiter, you have n commas. Why do I appreciate that? I don't have to change that line if I append another value. It looks much better in the Git history. Looks much better in version control. That's why I appreciate that. And I also appreciate that JavaScript realized that and now allows the optional trailing comma. JavaScript has followed that, and I do not appreciate that JSON wasn't updated for that. I wish there would be a new JSON specification coming soon that allows trailing commas, because that is just better for version control. And if you remove the trailing comma, in Go it's actually not optional, it's mandatory. It's a syntax error if you remove the trailing comma.
Is a comma necessary in the first place? Like just like semicolon, why is by taking that comma?
Very good question. I agree. If there's a new line, I think they could have gone that far in the language to say, okay, the comma is also optional. I think they could have done that, and they haven't. You see, even a new language like Go is already inconsistent. But very, very well spotted. I think we should introduce prizes for the audience for such comments, because it's really, I appreciate that. Very good attention to detail. Yeah, there's a question? It's basically in this regard. So the question is, how does it work if Go is by value? But you can create a reference. So when let's see if I have an example somewhere already. I don't have an example for that, but it's like in C. You can pass a struct or you can pass a pointer to the struct. So it's the same way. In Go you can declare whether you get a struct or whether you get a pointer to the struct. So if you don't want a copy, if you want the original, you declare a pointer. And in Java you always have the original, and that means in Java, that again goes back a little bit to the 90s programming, which was a mishap, you could say, in hindsight. If you look at classes in Java like point or dimension or location, if you do swing or AWT programming, are these mutable or immutable? Does anyone remember? They're mutable. Yes, they're mutable. They have setters, sometimes even public fields, dimensionless public fields. Now let's say there's a button, and there's some piece of code that wants to ask the button for its dimension. Can the button give the original? No, it can't. Because if it would give you the original, you could just modify the dimension and the button would be confused. Because the dimension would be changed, but the button doesn't know that it was changed. So what do programmers do in languages like Java? They do defensive cloning. When you ask a button for its dimension, you don't get its original dimension, you get a copy of the dimension. That pattern is called defensive cloning. And I'm not a big fan of that pattern, because what does it mean? You allocate memory. Do you expect a getter to allocate memory? Obviously not. When you're very strict about functional programming, then allocating memory is actually a side effect. And you don't expect a getter to have a side effect. Defensive cloning is not good. And we learned that, but now we also have the memory, so that we say, okay, now we create immutable classes. If you look at Java, the Java datetime API that was introduced in Java 8, which basically is just a copy of UDATime with like 2 or 3 minor differences. That's immutable. All the previous datetime APIs have been mutable. Java util date has been mutable, Java util calendar has been mutable. But now the new is immutable. Because we've learned that that is cheaper in the end than defensive cloning. With Go, you have to be careful in your design where you pass structs by value, because that is implicitly also a form of defensive cloning. Because you're passing around a copy. Or whether you pass them by reference. Yeah?
So, just to make it clear, it is not in your control whether you are passing by reference or passing by value. It is actually Go runtime which decide whether you want to make a copy or use it as a reference. Even though you make sure that you are passing or calling that function within that start. But it is Go runtime which decide whether you want to use by reference or by value. Even though you are saying it is by, you want to call by value, but at the runtime it will take a decision to make sure it is will be passed by reference. It is like a copy on write kind of thing. It is not always copy kind of thing. It is runtime will decide based on the decision. That is what Go says.
Right. You can only make that optimization if you're aware of the rights. And the only reason why Go can be aware of the rights is that when the Go compiler runs and links, it knows all code of the program, because it doesn't support dynamic loading of plugins. Yeah? And that's a disadvantage of Go. In Java, I do not have to recompile my program in order to support a new cryptographic algorithm. I just have to put the new algorithm on the class path, and I tell the user that this is a new string. Now we have SHA-4, for example. I don't have to rewrite any code. I don't have to recompile. In Go, that's not the case. Okay, so but we were also with annotations. We just deviated, and so another thing which is quite interesting if you compare Go and Java, how many visibilities does Java have? 4? I have news for you, it's 5. Since Java 9, it's 5 visibilities. You have private, package default, protected, public, and module exported public, which is the actual API. That's a difference that came with Jigsaw, with the module system. Now you can have a modules config.java file in your module that describes which of the publics is really public to be used as API. Because if you structure your module to have different packages, things have to be public just so that one package can call the other. But that does not necessarily mean that everything that you have public in your packages is also API to be used by the user of your module. So we have 5 visibilities in Java. In Go, there's 2 visibilities, and there's 0 keywords for the visibilities. Salutation is private. Now salutation is public. What changed? Exactly, the case of the first letter in Go decides whether it's private or public. That was a pill to swallow for me. I was really quite a casing fetishist about language, and I always despised Microsoft APIs for having verbs with an uppercase letter. For me, uppercase letters were reserved for nouns. And that's not only because of Java, but it's also because I'm German. In the German language, nouns are with uppercase, which might explain why Java is particularly popular in Germany. But in Go, okay, here is a noun, but the same applies to methods. That main is not public, is also special. Yeah, that doesn't need to be public. But if I wanted to have a public method here, like let's say t printf. That's one of the typical methods that you will write sooner or later for yourself. That's a public method now. And now it's private.
So we can have another method, main, with a capital M.
Yes. And that's not main. But also that is also not a main method, because the main method actually has to be in a package called main. Okay. So that's public and private. And the reason why I also went for public and private is we were actually at the topic annotations. This is how you do annotations. I think I forgot the quotes around that. How you do annotations in Golang. You can only put annotations onto struct fields. That's the only place where Golang currently supports annotations. There are proposals to expand Golang to support annotations in more places, and another very frequently discussed proposal right now is generics in Go. Go currently also does not support generics. And this tells the JSON serializer that if you read or write this from JSON, in the JSON it's actually called salu and not salutation. And now let's say we're using MongoDB, then if we want to have the same in MongoDB, then that would be the annotation for MongoDB. We put multiple annotations into the same annotator and just enumerate them with comma, and then you have the key and then the value. And the value, how it's formatted, that is annotation specific. There can also be things like that's something that's seen frequently. What if the field, the string is empty? Should the field be omitted or not? There are strengths and weaknesses about processing of JSON in Go. Strength is that it's quite simple to declare that stuff. Quite simple and straightforward. But JSON can do things that neither Java nor Go can do. In JSON there's a difference between salutation being absent and salutation being present but null. And yet another difference between salutation being present but the empty string. When reading a normal deserialization, your Go program in the normal way cannot differ between salutation having been absent, salutation having been present but null, and salutation being present but the empty string. They all look the same to the Go program. So when you have to connect to legacy systems where these differences in JSON play a role, you have to do a lot of extra effort with your JSON code in Go. When you're designing your own new code, it doesn't matter, because then you have control over that and you can say, okay, you just don't do that in your JSON. And I wouldn't do that in the JSON anyway, because it feels a bit weird. And it causes these types of problems. There are more annotations that you would like to have in code. For example, if you develop a microservice, how do you do documentation? What do you do for your microservices documentation? Yes, Swagger. It's the standard thing. Yeah? Has a few bugs, can't document everything, but popular. So we use it. And there's also libraries that document Swagger for Go, and they feel like Java before Java 1.5. You go back to your documentation comments. You do things like putting comments, and then you put things like description and status code and put stuff like that in comments. That feels very antiquated and awkward to a Java developer. There was a reason why we replaced Java doc as an abuse for annotations with a proper annotation mechanism. There were reasons for that. That's also why in the Go community they discuss expanding their annotation mechanism.
So I have a question regarding annotation in Go.
Yeah?
So annotation can be a key value there?
No, there can be multiple things. Here, where you'll have a key, but the structure of the value is annotation specific. So an annotation can decide how its value is structured. I haven't done much. I have never developed my own annotations in Go. It implies that Go also has reflection, but the reflection Go is not as powerful as in Java. Java is one of the most powerful reflection mechanisms, but it's sufficient for most of the cases that you would wish. But all I've done is declare stuff like this.
In Java annotations we can have annotation and it can have multiple values. Say
Yeah.
aggregate column name equals to something.
Yes, here you basically have two values. You have name and you have a boolean that is set to true, if you want to interpret it this way. Right, this is like the Java annotation, the corresponding would look like this. That is how the corresponding Java annotations would look like. And I can see Java is again more verbose. Java is almost always more verbose, except for the error handling. And I learned to appreciate the brevity of Go code. Yeah? Which is why I said in the beginning, the thing with the uppercase and lowercase letter, that it was a hard pill for me to swallow. But once I got used to it, I appreciated that I have more signal, less noise on the screen. Because in the end, public static void, for main for example, public static void, that's noise. Yeah? And what Go has shown to us is that you can reduce noise without losing specification. Because a lot of attempts of previous languages that try to reduce noise have lost specification. They have lost precision. I never found that Go is somehow ambiguous or feels too fluffy, not a bit mushy, not precise enough. I never felt that, despite its brevity. There are languages where you feel that they become mushy because of their brevity. They will still be unique in what they mean, but they feel mushy to a programmer. Has anyone ever done Perl programming here? You've done Perl, you nodded.
I've just seen Perl code and I know what you mean by that, like how brevity can just deter the readability of the code.
Yep. Because what is also quite important, that was very important for a language like Java, and that is the foundation of the success of Java, is you can have someone, put them in a team, and work on a production system that only know about 20% of the Java programming language. And they've never read the language specification. They can do that. They can be productive, which is very important for the enterprise. Especially, of course, in a country like India, where we have so many young people from the demographic dividend that we bring into IT jobs, which is very important not only for India but for the entire planet, because the demand of software is significantly outgrowing the availability of people that can do it. If you have a language like Perl, but when I write Perl code, I always have the manual about the syntax open. I can't do it without. If I would do it daily, I probably could do it without. Yeah, but a friend of mine actually calls Perl a write-only language because of that. Yeah. I mean, Don't get me wrong, I find Perl very awesome, and I still occasionally write Perl code, partially because of that brevity. But it's not code that I want to share with someone else, because I'm a kind person, or I at least try to be. Okay, so Go totally managed to be more terse, have brevity, without losing that precision, and also without losing that level that you need for the enterprise, for people that are not language cracks to still be productive in a project. And that's something I really appreciate about the language. Okay, so we had annotations. Then let's look at documentation. Both are very well documented. I like that about both. There's the API documentation of Java. I totally love it. It's so much effort put into it, reasonable effort. I know that not everyone appreciates that, and that's also completely okay, because it's just different types of people. And there are people that learn from the specification, and there are people that learn from the example. I'm a person who more learns from the specification. When I want to use a new function, the first thing I do is I open the API documentation. But not everyone is like that. There's enough other people that say, documentation, I first want to see how it's used. And they want to go for the example first. That's completely legitimate as well. And both languages in their documentation are quite good at that. I think they still, both of them, neglect the example people a bit. There could be more examples. That's something I even I notice, although I like to go from the specification. But both have been better than anything that's been there before Java. Go didn't beat Java on that level, but Go has beaten Java on a different level. So where do you look if you want to read the API documentation of JUnit? If you've downloaded the documentation, yeah, your IDE solves the problem. But where does it get the documentation from? Yeah. For that, it already has to be part of your project. Now let's say you want to read the documentation of a library for which you haven't decided yet whether you're going to use it. Where you're going to look? Either you create a playground project where you include it, or you Google for it, where it's going to be. If you're lucky, the developers have copied it and hosted it somewhere, and Google finds it. If you're unlucky, you have to download it from Maven Central and unpack it, or create a playground project, import it, and then you have it. That's something where Go is better, and I'll show you. That's something where Go can learn, where Java can learn from Go. This website, godoc.org, contains the documentation of every Go package that's public, even yours if you wrote one. Maybe not right now, but as soon as I enter the path of the package, it is going to be there. So when I enter github.com/Kinder/config Go, it's going to take a bit, and now I have the documentation here. And I might be the first one who's looking at this. This is a new library, and it's the first time I'm opening this page for the library, and there's a new library. Almost nobody else in the world knows about that library yet. You can also see I did not write any documentation. That's one of my plans for the weekend.
Similar to NPM, when you like publish your packages, you can see it.
Yep.
No, but NPM only shows the README, which is different. It is
Yeah.
at mercy of developer actually updating the redo all the functions. These kind of docs are usually generated from all the functions that you have or all the classes that you have. So this is really different from NPM in that.
Exactly. So this is API documentation. This is like Java doc. So like Java doc for Java, there's a tool called GoDoc for Go. And like for Java, there's a conventional syntax, how you write Java doc comments. There's also a conventional syntax for Go, how you write GoDoc comments. And this website can just import any package. And that, by the way, also already tells us a bit about packaging. What is the default packaging mechanism for a Java library? It's a jar file. What's a jar file? It's the binary. The default packaging mechanism for a Go library is you just share the Git repository URL. Yeah? It's on source code level, which for organizations who want to write libraries, which are paid libraries, is a hard pill to swallow. And because we've written so much open source, I don't mind if they suffocate on that pill. Because infrastructure software should be free. And all of us have invested so much time in making sure that it's free, that whoever wants to write a library and charge money for it should just go to hell. Because those companies, they all use open source. Every company uses open source. Even your bank is using open source. So,
If the packages are shared by a GitHub URL,
yeah.
how the versioning?
There are two mechanisms. There's the vendoring mechanism and a module mechanism, which both can deal with specifying the version number, and that then relates to a Git tag. But I can't tell you details about it because I only know that these mechanisms exist. I haven't used them yet. I didn't need to use them yet because how should you specify a version number? Does anyone know the specification that should be used?
Semantic version.
Exactly, semantic versioning. No matter whether it's NPM or Ruby or Java or Go, we should be using semantic versioning for version numbers. Which means we have 3 digits in the version number. We have the major, minor, and patch. Patch is what we increment when we do bug fixes. Minor is what we increment when we add new features. But both bug fixes and new features should be backwards compatible. And major is what we increment if we have backwards incompatible changes. Then we should increment the major version number. And I try to avoid ever having to do that. And if I stick to that, I actually don't even need to tag my package. But as soon as I do that, I really have to tag my package. And so just like in Java, this package had common documentation comments, and then they have just been extracted. And in the documentation comment, I even have put source code so that there's example code how to use that. That is, by the way, a library for a health endpoint in a microservice. And it supports the upcoming RFC. There's going to be an RFC. Currently, they're working on the 3rd draft of that RFC. And I've implemented that RFC. Because currently, whatever you use, Kubernetes or Google Cloud and so on, they all come up with their own specification for health. So they said, stop, let's standardize it. And currently it can report the version number and whatever you want with version information, the system uptime, the process uptime, other system information, like CPU utilization, memory. It can report the reachability of MongoDB databases and of SendGrid. And it's a proper framework, so you can add your own details for other health things, whatever you need. Yeah, and then you see how the documentation is extracted. And it's really awesome because if you want to read API documentation in Go, you just go to godoc.org. That's where you find all documentation.
So how the internal public libraries work in that sense? Like, let's say you have organization and you not all your source is open. So does it figure out like if we have hosted some packages on internal Git repositories?
Godoc.org is not able to show what you have on your private repositories.
Exactly.
It can only show things from public repositories. Private repositories you have to host yourself. Maybe the software from Godoc.org is open source, I haven't checked. Then you could host your own company-wide Godoc, for example. Yeah, would be possible. I bet it's open source. I bet you can do that.
I think Go has a command Go space doc and
Yeah. For generating the documentation, it's there. I mean, for hosting.
I think there's an option for web or something. Option called web or something which opens up a website.
Yes, it also does that, but only for one package. Or for the package tree where you are.
I think for the entire workspace.
Yeah. But what if you're a company and you want it for all workspaces? That is the question. Yeah. And then that's
this
what.
is to automatically generate, right? You can generate and upload it somewhere, but like the beauty of this one that if your package exists on GitHub, its documentation automatically gets populated on a URL, right?
Yeah.
So if you are an internal, if you have internal repositories, what is the way to do that? And second extension to that is also about sharing the packages. I mean, so does Go look at Git repositories just like Git URL or how do you share packages?
Let's look at.
Because you can't share binaries basically. Like in Java, when you have an internal Maven repository where you push your artifacts, right?
Yes. Let's just look at that. That will show how it's done. So we'll just look at some Go code to see that. And what you can see here is that when you import a Go package, this is a path. Well, so what happens here? Go is going to make an HTTPS request to that URL. So Go is going to perform get https://github.com/ and so on for the path. And the web server of GitHub in the web page that represents that URL has a meta tag. So when we open that, where does it come? No, let's just.
If it was a 404, then probably that won't be there, right?
Yeah, when exactly, you're actually right. If it's a 404, what it's going to do is it's going to remove the last path and try again. Which means because it couldn't find this, it's going to remove the uptime from the path, and then it's going to remove the next part of the path, and this page actually has it. And here it is. You have a Go import tag in the page that then says, this is my base path, this is the version control that I'm using, and this is the path that you have to give to the version control system to actually get that package. And that's pretty awesome. And that also means that the package management is built into the Go tool. What's the situation in Java? Java itself does not provide proper package management. People had to come up with Apache Ivy and Maven in order to provide package management. And the only reason why I use Maven is the package management, because everything else about Maven I find a huge pile of crap. It is a rape of XML. It's not that XML is a bad language, but people who make bad specifications based on XML, like POM XML, make all of us hate XML. And it's also awfully slow. Maven is awfully slow.
But Maven was actually Maven Central rather than the package execute. So
Exactly.
that is the format. Like after IB, of course, IB was the first thing to do
Yeah.
that. And then, so I would typically use Gradle in that case, like instead of writing form and do
Yes.
that stuff.
Because in Gradle, your file syntax is better. The build.gradle file is a better syntax than the POM XML syntax. But I personally don't see why I then should download 50 megabytes more build tool, because Gradle is also using the Maven libraries. So I'm downloading Maven and on top of that Gradle with its groovy part in order to have a smaller file syntax.
Yeah, but in Gradle you can do a lot of meta programming in the script, and you can.
Yes, I can, but I try to keep my POM XML files very simple. For example, I almost never have a build section in my POM XML. The only sections that I have is the typical artifact group ID stuff, maybe a parent, dependencies, usually dependencies in a bigger project by dependency management, and a few properties. I try to not have anything else in my POM XML files, because then I probably do something wrong or too special.
Yeah, but this is cool actually.
This is pretty cool.
It's just
Yeah.
But another problem that I see with this, again, it's not problem with the way we use it, but let's say GitHub is a source control repository. Now, your artifact repository should ideally be different from a source control repository.
Yes.
By artifact, I mean something that you produce as a library artifact, which is a jar file.
Yes.
And that is a binary. In both, probably because it is everything you need as source code while you are compiling your dependent projects also, it's fine. Same is case with JavaScript also. In that case, you need actual source to compile your own source. Having that thing is fine. But in world like Java, where you can actually share a binary, which contains class files and jar files, you actually cannot do this. Something like this is provided by Gitpack, for example. So Gitpack, you can point to your Git repository, builds that artifact and delivers it to you. But this thing is not even possible. And second problem that I see with this is GitHub probably should have problem with this thing. Now everyone who is compiling Go project on their local machine is continuously checking for Git repositories, all their dependencies, constantly. So I'm pretty sure GitHub won't have a directly problem with that, but actually you're continuously banging source repository, which would have been actually cached. These GitHub URLs are not really cached for delivery of CDN or something that's all. Your Maven repositories can be cloned locally, or you can do a lot of optimizations there. So you are actually like GitHub this URL. GitHub is not differentiating this URL like just help go.git. It does not know that you are deliver it to all builds that are happening worldwide. Right?
yeah, but for enterprise applications, you would have your own private
Internal Git repository.
or GitLab or something.
Exactly, but that is also still not optimized for artifact delivery. That is for
Yeah.
every developer that's building in there.
If we talk about artifact delivery, that just simply doesn't exist in the world of Go. In world of Go, you always share the source code. You never share the produce, unless the produce is a final binary that you give to the end user, and that is not managed with Go. That will be managed with whatever else release process you have. And when it comes to banging the source repository, I don't really see this as a problem. And what you've talked about, the efficiency of Maven, you have that in Go projects as well. That depends on how you structure your workspace. The normal workspace structure is that you have a in your home directory /go/source, and then there you will have the paths of these things. For example, I can just say go get github.com/schnellkinder/healthgo, and then it's gonna put that into my default Go root. So it's gonna that basically has done a git clone. And now when I go to go source github.com/kinderhealthgo, it's now there. And how I typically work is in our microservices project that I have the different microservices all in the same Go root, because, for example, when I use a library like HealthGo, I don't want to update one service and then weeks later the other service. I want to update all services synchronously. So I want them to actually work on the same library. Also, because it's source code based and not artifact based, when I make a change to one of my libraries, I want to immediately see wherever else I'm using the library, whether it still builds. So I want all these things in one workspace, which is a bit different from Java. In Java, we like to separate things and separate workspaces. In Go, I've changed my style of development. I've put more things in the same workspace.
Also because Go have like only these two visibility
Yes.
things, so it makes
Yes.
packaging simpler.
Yes, it does. So now we already covered parts of the packaging as well. That's good. So that's something where I think Java can learn from Go. This is GoDoc. I find that very awesome. Whereas in Java, I have to go to different places and hope that they actually ran JavaDoc and published it. And I think in recent years, JavaDoc also, I see a tendency to neglect JavaDoc and just rely on good symbol names. I appreciate the efforts of people putting it into better symbol names, but I think it should not come at the expense of good documentation. Okay, HTTP client, we actually already covered. HTTP server, both support HTTP 2 in the server, and both are quite equal in programming. So I'm not going to go in details. I could not find significant differences when you set up a server. The number of lines, the style, how you do that is quite similar. There's just one thing I want to mention there where I find Go very awesome. In Go, the HTTP library for the client and the HTTP library for the server is the same library. And that means that the HTTP client and the HTTP server also use the same types and interfaces for request and response. And I appreciated that very much when I started testing, because that just was very seamless. And it made it very easy for me to say, okay, I don't want to really go through the HTTP stack. I just want to fake requests and directly call them through my method. It was very easy. It was the same thing as making a real request, just instead of making the real request, calling my method, my handler. Very nice. That is where Go was better than Java.
Is it something to do with like all these newer specifications are written by Google developers now?
No, it does not. It doesn't have anything to do with the HTTP specification, the HTTP2 specification being written by Google. It just has to do with that the people who were writing the HTTP client and the people who were writing the HTTP server in Go either were the same people or were people that talked with each other. Whereas in Java, you can see that the people who wrote the JDK HTTP server and the people who wrote the new HTTP client, they were either not the same people, or if they were the same people, they were schizophrenic and the two minds were not talking with each other. It's just you take Jackson into account. And most people that use JSON or XML mapping actually use Jackson for that in Java. Build times, turnaround times. That is something where Go totally beats Java to the pulp. And that is not intrinsically the fault of Java, because the Java compiler itself is actually very fast. But until Maven or Gradle got around to actually call the compiler, it can already take like 2 seconds. In that time, Go has not only compiled but completed the unit tests. That's a big difference. And I'm actually, there's only one thing that holds me back from going back to makefiles for building Java projects, and that is that no one has written a dependency manager. That part of Maven that I'm interested in for GNU-Make. Maybe I'm going to write one myself. Then I'm going to go back to makefiles. Because Java itself is fast. It's the tools that we're using, like Maven, Gradle, and SBT, that totally suck. Who of you has already tried to build an executable jar archive with Maven? Has anyone ever tried that?
The fat jars one?
A fat jar, yeah? With a main class. How many lines do you have to put into your POM XML in order to achieve that?
I don't remember, like it must be years back. Now I do that with Gradle, and that's quite easy with Gradle too.
With Gradle it's much easier, yeah? But if I look at this, I'm actually gonna show you. Because
and while we are there, I really want to discuss things changing with Graal, for example, now. How things are changing with Graal VM on Java. Because that compiler is actually producing the native thing and all of it. It's slow right now, but it can actually produce your OS targeted binaries directly, so that your JVM cold start and all those things are avoided.
I haven't looked into it because for me it didn't do anything new that the GNU Java compiler couldn't do. But I'm also not very interested in producing binaries. I mean, when I use Go, I produce a binary and I'm happy about that. But when I use Java, I produce a jar file. I'm also happy about that. And when I really want a binary, a real binary, a proper binary, I would not use Java, but I probably also still would not use Go. And I'll quickly show you why. Let's first do that. Let's make a hello directory. See, I'm so used to Java that I put a semicolon. I forgot an import. So, how big is this Hello World program as a binary? 2 megabytes. 2 megabytes for a Hello World. Let's write this in C. We can actually use puts in that case. How big is that Hello World? 16 kilobytes. If I want to produce normal binaries, I'm reasonable about what is the impact on the user, who might be a normal Linux user, who has a package manager, who wants to update their software regularly, what stuff do they have to download? I still don't use Go. I think Go is awesome for microservices. And I think Go is also awesome for prototyping. And Go is awesome for everything that you want to do in Go. Yeah, so I have a code generator in Go that goes to the YANA page to look at all the MIME types. Go is not yet very good at it. I think whatever Go claims about being streamlined, this Hello World sign. And in POSIX I have and true, and then echo, and then cat, and ls, and head, and tail, and sort, and so on. I think that's a good way how to learn a new language. And the false program in Java. Now I want to have this as a executable jar file. Yeah, let's just do it this way. Why is it so complicated when I do it in Maven? Maven is supposed to make life simpler and not more complicated. And the same, by the way, also still true for Gradle, in my opinion. We've been hammered in the wrong reasons why these tools were introduced. Why was AND introduced over make? The reason was because people were using Unix and Windows, and they wanted something that's portable between them. That's what they wanted. They wanted a portable build tool. And then from there, it went downhill all the wrong route. Do you know the binary size of GNU Make? (230 kilobytes). And I think that still is the best build tool. Now let's look at the true command. The reason why I say now let's look, and the directory structure that I need in place and do the same thing that I did with 2 command lines that I would have put in a makefile of 5 or 6 lines. I think regarding build automation with these tools, and then your builds will be faster, much faster.
This JPMS thing has not changed the way manual should work now from Java 9?
No.
It still has to download dependencies to the
But again, what about the info files?
Yeah, that is just about deciding whether I can access the CPI or not in that sense.
Exactly.
But, all the pre-processing that happens before that, checking the metadata of the jar and all those things, downloading it again, all those things still happen. So, but I little disagree on this point. Like, so far as Gradle what it does is, or a lot of these build tools they do is, they actually check what all needs to be recompiled or not. So, of course, just pure compilation speed, JavaC can just compile fast. But for which all file you have to actually recompile? Because while you are developing the project continuously, you have to only compile selective files. They form a dependent DAG kind of structure through which they detect whether your file actually needs recompilation or not.
The Java
So
compiler, the Java compiler is so fast that if you recompile 100 or even 500 files, it still just takes like 3 or 4 seconds. That's what's often forgotten in that case. And I mean, one reason why people were using AND is if you do the old style make on a Java project, it would mean that you invoke the Java compiler separately for every single Java file, and that's very inefficient because the Java compiler is written in Java, and then you have 500 source files, so you start the virtual machine 500 times. That's inefficient. But if you give the one Java compiler 500 files to compile, it will just take like 3 or 4 times the amount of time it takes to compile a single file, because half of the, or a third of the time is starting the virtual machine, a third of the time is initializing the compiler, and only the other third of the time is the actual compilation.
So for in Gradle again, I'm just thinking of that. It actually keeps the compiler JVM hot. So there is a
the Gradle daemon.
Which stays hot. So actually it's not a startup time that's taking time. It's actually compiling.
I know, and I use Gradle in Android projects or React Native projects, and still I find it very slow.
That's probably because of React Native and Android, rather than just Gradle in Java, honestly. I totally agree.
It's multiple things playing together. Yeah, but when I replace Gradle with a Makefile, it usually is significantly faster.
On smaller projects, on bigger projects, that will turn out to be faster. That's my observation again. It may mileage is very good.
To give you another example, I mean, it also depends a lot on how well the Makefile is written. I've worked on a project which, when I joined that, had about 400,000 lines of code. There was like 70% or so C, 25% Java, and 5% assembly, approximately. When I joined there, it took about half an hour to build, and everything, oh, Make is so slow, and so on. I know you're just using it wrong. I refactored the build, and then it took 2 minutes. And I wasn't even done. Yeah? I already had a prototype on my machine which took just half a minute, but before publishing that, I actually left that company. Okay, so what do we have as differences in the build? So the Go tool handles dependencies, compilation, and bundling. Bundling in that case just means building a binary. Libraries are distributed as source. That is good and bad. As an open source developer, I think that's good. If I put myself in the shoes of someone who is used to closed source artifacts, it's bad. Java itself, it only handles compilation and bundling, but bundling requires additional configuration. I don't need to tell go build where is my main class. It's automatically detected from where I build and what is there. Only in case I have multiple main functions in the same main package, then I have to tell the tool build this and build that. And for dependencies, I have to have a third-party tool like ID, Maven, Gradle, or SBT. And bundling also requires additional effort when I use these tools. Libraries are distributed as binary. That's the main differences that I see there. Okay, then I had to do a little bit with cryptography in that project. So I compared, and one thing where Java totally outperforms Golang is in how you handle cryptography. In Java, I can just put a jar with new algorithms on the class path, and they're available at runtime to my program. I don't need to recompile my program. And I also like that the algorithm identification in Java is a string. I have a string that says SHA-1 or SHA-3. And in Golang, that's an enum of ints, which means it's also not extensible by third party because it's not string, which I find very strange for a new language like Golang to do that. When it comes to the number of supported algorithms that are there out of the box, Golang outperforms Java. Although that was done on Java 11, I haven't updated it for Java 12, but in the release notes I couldn't spot anything about new algorithms, so I think it's probably still true for Java 12. And another topic where I was very disappointed, I was so actually not just disappointed, so blocked by the features or the lack thereof in Golang, that a service that I started to write in Golang, I scrapped it and rewrote it in Java with XML. There's nothing that beats Java when it comes to XML. In Golang, we have support for XML 1.0. XML 1.1 is not parsed in Golang. In Java, I can use 1.0 and 1.1. In Golang, out of the box, I have no validation. In Java, out of the box, I have xerxes available, which can validate document type definitions for 1.0, 1.1, XML schema, and I haven't put it on the list because it's not the World Web Consortium specification, but can also actually validate relax and G schemas. Then when it comes to XML namespace support, namespaces are just supported in 1.0, here in 1.1, and also whatever you need in the infrastructure for namespaces is not really good in Golang. I couldn't find X-include support in Golang. I love X-include. I use it a lot in projects where I have XML as a document language. There is no out-of-the-box XSLT support. You can get XSLT support with libXSLT, but that's a C library plugged into Golang, and I would always be very careful about using C libraries in Golang. It's not that this is a bad thing. Actually, a lot of Go itself is also developed that way. But when you have an inexperienced third-party developer doing that, you have to keep in mind that Go can only garbage collect its own memory, but it cannot garbage collect the memory that was allocated by C. Which means that whenever you use a third-party library in Go that is implemented in parts or in large parts in C, you have a risk of memory leaks. When you're developing a standalone application, a binary, that probably doesn't matter because it will run for seconds and then the job is done, if even that long. But when you're developing a service, you want to have 24/7 uptime. You can't have memory leaks in a service. Which reminds me of my latest Google Cloud experience. I have a Go program hosted on Google Cloud, and it typically uses about 50 megabytes of RAM. Complete process, everything. So I go for the smallest instance, which has 768 megabytes of RAM. What do I do with all that RAM? But that instance keeps locking up and crashing. And I debugged why. And FluentD is running by Google itself on that. And that uses up to 80% of the instance's memory. And then when it, for whatever reason, uses even more, the instance just hangs. I can't even SSH into it. I have to report that back to Google.
We have had problems with FluentD as well. And it used to crash.
Mm-hmm.
The main service was Java. And we suspected Java crashing, but actually it was Fluentd.
Yeah. And then when it comes to DOM, I like DOM because I quite often want to write programs that can deal with XML, but I want to write them in such a generic way that they know as little about the actual document and the actual data as possible. I want the program to be as generic as possible. That's exactly for which SACS and DOM APIs were created, and that's just not available in Golang, and trying to do that in Golang is a pain. Yeah? So at one point I actually had to call a service that uses SOAP. Terrible. Has anyone here ever done SOAP? How do you feel about SOAP? Why? I hope you're not just saying that because I just said it. I didn't want to make a precedence for that.
Handling them is really, it's too much to do.
Yeah, there's just too much effort to get a simple thing done like a method call. It's just too much effort that you have to do. And I completely agree with that. And I think whoever decided the name for SOAP probably is a psychopath. Because what does SOAP stand for? Simple Object Access Protocol, but it's the opposite of simple. Gladly someone wrote the REST specification, which is just a reminder how simple HTTP is. So I had to use a SOAP API because I had to pull data out of a third-party system that has a SOAP API. That SOAP API was so old and crude that even Java's SOAP library didn't work with it. So I had to go back to bare metal XML. But that was something that was just much nicer to do in Java than in Go. So if you have something that's XML heavy, I recommend stay away from Go for now, until they've brushed up their XML libraries. Especially if you want to do heavy lifting in XML, to message-oriented messaging or presentation-oriented publishing, where you want to connect services with services and translate between different formats, like you want to connect Oracle with SAP, the XML that they exchange for invoicing or something like that. Don't even think of Go when you want to do that. Stay with Java. So, what can they learn from each other? I think Go can learn from Java sometimes simpler code. Yeah? For example, when it comes to error handling, Go should have exception handling. Also, Go should introduce generics. I can't write functions that operate on types that they don't know yet in a nice way. There's no nice way how to do that in Go. And also, TDD could be slightly better. TDD works in Go, but when you compare Go testing with JUnit, Go testing is just very inferior compared to JUnit, especially JUnit 5. JUnit 5 really rocks. And also when you do services in Go and you want to use Selenium for testing, you'll not use Go for that. A very simple reason for that, there's basically no Selenium for Go. So you're going to use JavaScript or Java. If you want to use Selenium, my recommendation is use Java, don't use JavaScript, because in JavaScript, Selenium is asynchronous, but when you want to use a proper test framework on top of Selenium, you then want to use something like Cucumber. And I've tried to use Cucumber with Selenium in JavaScript, and that's a pain. It was such a big pain that I said, I don't want to do this to my colleagues, we'll do this in Java. And in Java it's just completely painless. Then what can Java learn from Go? Also sometimes simpler code. Especially we developers can learn something. I actually, in my own projects, I already stopped putting getters and setters in my data structures. And you know what? It works. All libraries that I've used, no matter whether it was like JAX-B for Java, the Java API for XML binding from Sun/Oracle themselves, or whether it was something like Jackson's object mapper, they all just worked fine without getters and setters when I made the fields public. They can do that. They work. So I can simplify my Java code a lot. Java can also learn from Go faster tools. Yeah, the Go build times are just much better. And I just like Go source-based dependency management. Especially when I use the same library in multiple projects. Yeah, but when you have a big project, it is inevitably the case. Or when you do microservices properly, it's also inevitably the case that you're going to use libraries for cross-cutting concerns like configuration, auditing, logging. They want to use the same libraries across multiple projects. And it's also quite often the case that you're not satisfied with out-of-the-box third-party libraries. So you're going to write your own library, or you're going to write a wrapper for that library. And then when you want to update these things, I feel that Go is so much nicer when you want to update a big project as compared to Java. Within Java, how it typically works is, okay, you update that library, you have to predict whether it's going to work, then you're going to push the code, Jenkins is going to build it, put it into your own artifactory or whatever you use for that, and then you go to the other project, you go to the POM XML, you update the dependency to the new release, and then you're going to check whether it's going to work. That's quite a tedious process. In Go, I go to my Go root, I update the library, I compile everything and see if it's still working. Much faster, much better. Okay, any questions so far?
What about the threading model?
That's a good question. I think there's that typically is a question because people talk about threads, but they actually want to talk about something else.
Concurrency.
Exactly. And then people start comparing things that should not be compared with each other. So Go for concurrency has so-called Go routines. And Go routines are currently implemented as green threads on top of OS threads. So Go is going to spawn a couple of OS threads, and that's going to depend on the number of cores and the need. Yeah, so Go is not going to spawn lots of threads just because it can. It waits for the demand. Yeah? But then it will not spawn a thread for every Go routine. It will spawn a number of threads that is reasonable for the number of cores available. And everything else on top of that, it's going to do with green threads. What's a green thread? A green thread is something that for a programmer feels like a thread, but the scheduling is not done by the operating system, but by the runtime environment. Why are green threads faster than native threads?
When do optimization in the program, what piece of code needs more execution time and all? Rather than always deciding
It's actually
other system resources availability.
Yeah, but it's actually not about it's about a very particular CPU resource, a very particular part of the CPU.
The caches?
No. The context switch. What does the context switch have to switch? The register bank. And the reason why green threads are so much faster than native threads is because Intel have messed up the CPU design. Because they've put so many special registers into the CPU that the context switch by the operating system is slow. Because the operating system doesn't know which registers you use on an Intel CPU. Therefore, it has to switch everything. That green threads are so much faster than native threads is not a universal truth. It is true on Intel and AMD CPUs, But it's, for example, not true on ARM CPUs. On ARM CPUs, the difference between green threads and native threads is negligible. So on a in a green thread model, the Java virtual machine or the Go machine, they know because of how they work, because how the Go compiler works, or because how the Java virtual machine and just-in-time compiler are written, what registers they use, and therefore they know what they have to switch. Green threads are not all light, there's also shadow. If you use threads and you think you have a thread and you make a call to C, it matters whether you have really a separate thread or whether you don't have a really separate thread. That can matter a lot for C libraries. That is a pitfall for Go programmers. They have to make sure in their native code that if they need separate threads, that they really are on separate threads. In Java, if you have a thread, you have a native thread, so you really are on a separate thread. So in Go, with the Go routines, the syntax is actually quite nice. So that's your separate thread. And people compare this with the following Java code. And say the Go code is simpler and the Go code is faster. But these are not the same thing. That is not a good comparison, because if you just want something asynchronously, usually we use threads also as cargo code, just like the semicolons. When you want to do something asynchronously in Java, what you actually should do is you should submit a task as a callable or runnable to an executor service. That is what corresponds to a Go routine. And then in Java you'll also get a green thread and not a native thread. And then Java, so if you compare those two things and you do something where you say, okay, let's spawn 10,000 of them or 100,000 of them, and you measure, you will see that Go totally outperforms Java. And the reason is because Go uses green threads in that case, and Java uses native threads. But that is because thread in Java has been redefined not to be just an arbitrary thread, but has been defined to be a real native thread, so that native programming, the C libraries, is reliable without having to do any magic in the C code. And as soon as you change the Java code to be an executor service, what I measured is, in this plain example, Java then outperforms Go. I will also publish that code. Yeah, then if you do something inside like MD5, then again Go outperforms Java, because somehow Go's MD5 implementation is faster than Java's. But it means whoever tells you one thing is faster than the other, no matter which way round, caution. And I'm always cautious when people that use new stuff claim it's so much better than the old stuff, because we should never forget about resume-driven development and justification need. Yeah? Sometimes the old stuff isn't that bad. There's still so much C code being written that people are often not aware of, but you just have to open your wallet in order to see applications that use C. All the banking cards that you use, most of that is written in C. Or look at your phone. The kernel is written in C and the SIM card is written in C. So old doesn't all necessarily mean bad. Does it answer your question about the threads? Any other questions? Okay, then we are at the end of the talk. I hope you liked it. And you can follow me on Twitter, and you can follow me on GitHub, and look at my open source projects. And of course, you can talk with me after the talk. I hope that we have some snacks now, sandwiches or so. Thank you.
Folks, we have a feedback board there. Before you go, please give us some feedbacks. Negative, positive, anything.
And please use the left column only, the other columns for the other speakers.